Select the major product of the following reaction. So we see that we are given two equivalents of an ester, and we are treating this with a base. And now this base could attack the carbonyl, but we should notice that the base is the same as the leaving group. So if that happens, that would just give us back the same ester. So hopefully we can recognize that these conditions are not for the transesterification, but that they are for a Claisen condensation. So in a Claisen condensation, what we're doing is we're bringing together two molecules of the ester, and we are losing a small molecule. That's the definition of a condensation reaction. So what's going to happen in this first step with your sodium methoxide is that methoxide is a base, and it's going to convert some of this ester to the enolate. So we can show that happening. Right? So we have that methoxide, and it's going to convert, as we said, some of this to the enolate by removing one of these alpha protons. So I'm going to draw the structure of that enolate, and we're going to acknowledge that this is an equilibrium by putting equilibrium arrows there. So here is the structure of our enolate. So we're only converting a small amount of this to the enolate, and it's going to react with the remaining ester in that Claisen condensation. And what that will do is it'll remove this enolate from the equilibrium once it reacts. So then the equilibrium will shift and form a little bit more, and it'll react, and the equilibrium shifts and forms more. And that's how this keeps on going. So what I'm going to do is I'm going to draw another equivalent of this ester. I'm going to draw it in a different color so we can keep track of our carbon atoms. And I'm flipping it around so I can put the carbonyl a little bit closer to the enolate, because this is where we're going to react. The nucleophilic enolate is going to react with the electrophilic carbonyl. Okay, and so we have seen these mechanisms here a few times. So what I am going to do is I'm going to do a bit of a shortcut. I don't think we need to draw the entire mechanism to get to the product. So what we're going to see is we know that this enolate is going to attack the ester carbonyl. And because this is an ester, because we have a leaving group, it's a nucleophilic acyl substitution reaction. So we're substituting this enolate for the leaving group. So here's where we're going to take a shortcut in the mechanism. We're going to recognize that the electrons come up onto the oxygen. You get a tetrahedral intermediate that collapses and kicks off the leaving group. So I am just going to do a shortcut here to say these electrons went up, they came back down, and we kicked off the leaving group. So we're going to make a little note that this is a shortcut and not a valid mechanism. But this is a fast way to get to the product. You don't want to always spend your time drawing the entire mechanism, because that can eat up quite a bit of time on an examination. Okay, so what I'm going to do here is I'm going to draw where my attacking enolate was. And here's the alpha carbon that's forming the new bond. So I want to show my new bond here. So I'm going to draw that new bond in green. And I'm going to keep drawing the remainder of this ester. So I've got, let me number the main carbon chain. So 1, 2, 3, 4, 5, 6. So I want to make sure, so this is 1, 2. I'm going to draw the rest of the chain going down this way. 3, 4, 5. So 3, 4, 5. And carbon 5 is a branch point where we've got these two methyl groups. So either one of these we could label as 6. So we've got that chain going down. And I'm going to draw this portion of the molecule in pink so we can see where it's coming from. So again, let me number the chain. So there it is. And so we've got the carbonyl. We've lost OCH3, so you've lost that as a leaving group. And then you've got the remainder of this chain. So that was 1, 2, 3, 4, 5, 6. And we have a methyl group on carbon 5. So now what I want to do is just find that down here. So there's really only two possibilities. It looks like it's either A or D, and a simple exercise in counting will tell us which one. So it looks to me to be D, because this really looks like the same shape. Let's go ahead and throw some numbers on here to be sure. And we can see that 6 carbon atom chain, and it's angled differently, but this carbonyl should be this one here. So 1, 2, 3, 4, 5, and 6. And so we've got to the product.